A project title is a rehabilitation method for developing a humanoid robot for training and autistic children. The components of a project is Atmega microcontroller 2560 board, L298 IC chip, LCD display, battery, Bluetooth, micro servo motor, mini TFT display, and vibrate sensor, flux sensor, force sensor. I'll explain the abstract of a project. A project focuses on developing a humanoid robot which will give solution for some of the bigger issues like hand flapping and toe walking of autistic children. We demonstrate three sensors like vibrate sensor, flux sensor, and force sensor. First, flux sensor is used to reduce the hand flapping of autistic children. When the audio is played, it reduces the stress level of a child's mind and make them to grab the instruction from the audio. And a force sensor is used to reduce the leg movement of autistic children. And vibrate sensor is given in a child's hand. It reduces the hand flapping. Then we use a PID algorithm. It means proportional integral derivative algorithm. It is a control algorithm which tries to compensate the characteristics in the system. I'll explain the existing system now. In existing system, a modular humanoid robot is used to train the child like Inevo, where the humanoid robot will train the child by giving different positions and expressions where the child intimate and learn different signs through this. Whereas in proposed system, we use a biped humanoid robot instead of a modular robot, where it provides the solution for drawback of the existing system. Piper humanoid robot gives the solution for bigger issues like hand flapping and toe walk of autistic children. This system uses an Atmega microcontroller board which is programmed by open source ID. Now we also created three apps. One is AMR voice controller, gesture control, and Google Voice. First, gesture control is used without internet, and Google Voice is used with internet. Without internet, I'll tell you first. If you press forward, then the robot will run in forward direction. If you press right, then the robot will walk in right direction. If you press left, then the robot will walk in left direction. If you press back, then the robot will come in backward direction. In gesture control, then in a voice, Google Voice, we have to tell go left, go right, go back, and go forward. Then the robot walks as per the Google Voice.